Welcome back to the data structure tutorial, and today we will be implementing the code for operations on doubly linked list. In the previous video we have just written the algorithms for deletion of a node from the various positions of doubly linked list. Now let us start. In the previous implementation part we have just written the code up to the insertion of a node at the middle, beginning and the end condition. So after this function I'll be creating a new function here in the previous class, that is DLL operations. So that I'll name that function as delete. This function will receive the data from user which is to be delete, and then the very first condition we will be checking that whether the existing list is available or not. So the condition is if your starting pointer, if your start is equals to null, it means that you do not have a list, and you will be displaying that message to the user that your list is empty, and you will be returning from here itself. Okay, and else it means that you have an existing list. So your task is to search in which node this data is present. So for that we have initialized one pointer, that is p, to the start. Then we'll be applying one loop to scan entire list to find out that node in the information field of each node. So you will be writing p of info is not is equals to your data. Till then move your p forward, but before moving copy your p to the queue, and you will be writing p equals to p of next. So this is the logic to search that node. But what if you are moving forward and you will be finding that somewhere p becomes null. So if somewhere p becomes null, what it means, you will be displaying one message that your data is not found, and you will be again returning from here itself, return. Okay, and this is the logic to search a node from the doubly linked list. This is what we have written in every algorithm. To search the node you have to write this much logic. Okay, now you search the node and it is pointed by the p, and we have to check that whether that node is the first node, that is at the beginning or at the end or at the middle. So how do you know that? So what you will do, you will be just checking the address of p. So if the address of p, which is your node to be delete, if it is equals to start, it means that it is your a node at the beginning, and you have to write the logic for the beginning, deletion from the beginning. So you have to make the next field as a start. P's next will be copied into start, so this become your starting point, and the starts previous should be null, and then P's next should be null, so you will be detaching the first node. So here start becomes your P's next, so you appointed next node as a starting point. Okay, then that new starts previous node should be null, so the previous connection will be detached, and P's next will be again null. So what will happen, this connection will be broken, this one, and in the previous line this one. So you just return the algorithm for deletion of a node from the beginning. If p is not at the starting point, so you have to check another condition, that is else if. And what is that condition? Okay, if it is not at the beginning, it may be at the end. So what is the logic for the end? If this is the p which is to be delete, whose next field will be null, it means that it is at the end of your doubly linked list. So you will be checking if that p is next is equals to null, means it is a last node. And if it is a last node, what logic you are implementing, q's next should be null and p's previous should be null. That is what we have written here. So you have to write q's next field should be null, so it will detach the last node, and p's previous field should be null. So automatically that will be detached from the existing list. Now if these both cases are not there, so obviously that node will be lies inside somewhere in the list. So that is the middle case of your deletion of a node. So in the middle case, if you delete this p, you need to copy this address 500 into the R. So P of next to be copied into the R, this line. So you will be writing that R is equals to P of next. We have declared all these pointers earlier in the code here at the top of the functions. Okay, so we copied the R. Then you can see that in the Q's next it should be R, and R's previous should be Q, and P's next and previous should be null. So Q's next to be R, R's previous to be Q, then P's next to be null, and P's previous to be null. So we have just written the all the implementation of algorithms for deletion of a node from the doubly linked list. Okay, now let us write another function to display your entire list. So after this deletion function here, I'll be creating one more function, that is void display, and here we want to display entire list. So we'll check that if again my starting point is equals to null. So what it means, we do not have a list to display. So we'll print one message to the user that list is empty and return back from here itself. Else, if it is not the case, then print all the elements of your list. So we'll be starting from start. So we are assigning the starting address to the P. Then we'll be applying the loop till P becomes null. P is not equals to null. Till then we'll be printing up values from the P. So how will you print that values? We'll be printing that values as P dot info, because that's information which we want to print, and after printing move your P to the next location. This is how we move our P to the next location. Okay, so what will happen? P's info will be printed, P will be at the next position, P's info will be printed, P at the next, P's info will be printed, P at the next, P's info will be printed, P at the next, and if P is a null, this condition will false and it will stop the loop. So we have written the function for displaying all the list of doubly linked list elements. Now we need to call it. So from the main method we will be calling that. So every logic for the insertion and deletion and display we have written under the class DLL operations. So here inside the main we need to create an object of DLL operations. We'll be creating with the name OP is equals to new DLL operations. So once you created the object, you will be calling the function. So I'll be calling op dot insert at beginning. Suppose I want to insert a element 33. That is my first element. Then I'll be calling op dot insert at end, and I'll be inserting suppose element 44. Okay. Then again I'll be inserting element at the middle. Sorry, it should be insert at middle. What element I want to insert, suppose 55, but after which element? So we need to pass the position as well. So I want to insert that after 33. Okay, so what sequence I'll get? 33, 55 and 44, because 55 is added at the middle. So after 33 you will get 55. So let us check whether our code is working fine or not. So we just call display, and now let us run this. So I'm executing it manually. So I'll be clearing my console. So compile it javac demo dll.java, and then java demo dll. So it will gives you the output. You can see that the first element is 33, which is inserted at the beginning, this one. Then insertion at the end, so we inserted 44 at the end. Then we inserted 55 after 33, so it is correctly inserted at the middle of the list. Okay, now let us add few more elements. So I'll be adding that element at the end. So I'll be adding suppose 66. Then I'll be adding op dot insert at end, suppose 77. Then op dot insert at end, again I'll be adding suppose 88. So we have added enough elements. So let us display that again. So you can see that of 33 is the first, 55 is the middle, 44 is initially at the end, then at the end we added few more elements, 66, 77 and 88. So last added element is 88. So list is clearly displayed. Fine. So to make it clearly understandable, what I'll do in the display method, I'll be printing one message that doubly linked list is okay. And now okay, so we added enough elements, we displayed also. Now we want to delete the element from different locations. So op dot delete, what element you want to delete. So let us start from the beginning. So I want to delete 33. Once you delete, then display it again and check whether it is deleting the first element from the list or not. So compile it, run it and check. So once you compile and executed, you can see 33 to 88 the elements which we have added. Then we instructed the code that you should delete 33 and then display the list. So you can see that 33 is deleted here and the remaining elements are displayed as it is. So we have successfully deleted from the beginning. Okay. Now again a delete element which is suppose at the end. So 88 is at the end. So I'll be deleting 88 and then again I'll be displaying it. So I'll call display. So let us compile it again and run. Okay, we'll check the output. So here is the original list. Then we deleted the 33. So after 33 deletion, this is the list. Then we instruct the code to delete 88. So 88 is deleted. So deletion from the beginning and 8 both are working fine. Now let us try for deletion from the middle. So I'll be deleting an element, suppose 66, which is at the middle of my list, and then I'll be calling op dot display. So let us check here again. So compile, then run, and you can check the entire operations now. This is my existing list. We instructed 33 to delete, so it is deleted from the beginning. Then we instructed 88 to delete, so it is deleted from the end. Then we instructed 66 to delete, which is at the middle in the previous list. So 66 is deleted and you got the final elements as 55, 44 and 77. So this is how we implemented all the operations on doubly linked list. So I hope that you will be following entire series and you will be completing this code and getting your output. So we'll see you in the next video.